big thanks to all who subscribed, liked, and commented. Much appreciated, and I hope the videos provide some help and assistance with your projects. This video takes a basic look at FreeCAD's Spreadsheet Workbench and how it can be used to organize dimensional data and parameters. The goal is to make parametric models work more easily. Welcome back. Thanks for watching. There's some links in the description that will augment the material that we're going to go through today. So let's start with opening up FreeCAD. The version I'm running is going to be right here, Real Thunder. So the build and version information is right here, just so you know what I'm running. So we've got that out of the way. Let's go ahead and open up a simple model. This is the same piece of sheet metal with one bend in it that was used in my previous video on the Make Wall tool. So let's take a look at something you may or may not know. If we go into Edit and Preferences, we'll go up here and we'll go into the units. The default here is 2. I've set mine to 3, so you can play around with that, and that will also affect the spreadsheet that we're going to use today. So set that up as you feel appropriate. And I'm going to stick here with millimeters, which FreeCAD seems to be most comfortable with, so we'll just leave that alone. So the next thing to go into is the model tree. We'll double click on this to make this body active, and we'll go into the sheet metal workbench. And just to recap what was covered in the previous video on the Make Wall tool is how to select the edges, the faces, and so forth. What happens here is if you select a face, FreeCAD appears to get a little confused with whether the Make Wall is going to bend up or bend down, and that kind of randomly gets messed up when you change the model parameters like the length and the width, which is a little frustrating. It's a little embarrassing too, since the fix for this is real easy. I spent a number of hours playing around before I finally figured this out. So the way to do this is if you select this edge, the Make Wall is going to bend in the direction of the cross section. So if you select this edge, the bend is going to be down, and if you select this edge, the bend is going to be up. So we want to make this look like a box. So we'll select this edge, and then Control click is the additive select, and we'll go over here and select this edge, go into the Make Wall, and we'll take the defaults for right now, and we've got 3 bends here. It's working as expected. So that's how we get started here with that. So the next thing is to go into the Spreadsheet Workbench. We can go up to this icon here and create a spreadsheet, which throws it in the model tree. So we'll double click on that, and we've got a spreadsheet. Just be advised that this is a rudimentary and basic spreadsheet tool. Works pretty well for what it's intended to do. It is not an Excel spreadsheet. It is not a Libre Calc spreadsheet, so it lacks a lot of the fancy features and functions. But as mentioned, it works pretty well. So what we'll do is we'll create some column headings, and we'll start off here with height and width and edge and thickness and K factor, and we'll finish off with bend radius. So all we did was just create some column headings. We'll do a little bit of editing. You can go up here and center these. It's optional. You don't have to do this, but I kind of like it. So here we can enter some data. So I'll go ahead here and put in 100 millimeters for the height, 50 millimeters for the width, 12.7 millimeters for the edge, 1.6 millimeters for the thickness of the metal. 0.4 is about what I use for the soft aluminum that I bend, the K factor, and then the bend radius is going to be 1/16 inch, which is about 1.6 millimeters, which is what my tooling is. So FreeCAD recommends that these numbers be given dimensions, so we can go back here and add those dimensions in. The designation needs to be right after the number. Can't have any spaces in there or it's going to complain. So we could have done this at the time we entered it, but I didn't do it, so we'll retro enter it here. This is a dimensionless constant, so it doesn't get any dimensions. And this gets millimeters here. So we've got columns A2 through F2. And we can do the formatting here if you like. Center this up and make it look nice. So we've got variables here now that we can include in the model. So let's go back into the pad properties and let's do material thickness, which I've hard coded here as 1.6 millimeters. So we've got go back into the spreadsheet, and that's going to be F2 is what we're going to want to put in here. So we go into this and we've got this little f of x expression formula editor. So we'll go in here and we'll type in spreadsheet, pick the autocomplete dot F2, and there's our 1.6 millimeters that comes up. So that now has been tied to the spreadsheet. I'm not going to see any change since we went from 1.6 to 1.6. We can go back into height and width. We'll kind of jump around here a little bit. So that is going to be in the sketch. So we'll go here and double click on this, go over to our expression formula and spreadsheet.A2, and that's going to be 100 millimeters. Not sure what's going on here with units discarded. If anybody has any input on that, would appreciate a comment, but the units are in there. It is millimeters, and it's kind of giving me this warning. So we'll just sort of let that go, and let's go down here and we'll select this, double click. Same thing, go back into the formula and spreadsheet, and this is going to be .B2, which is our 50 millimeters. So let this recalc. So that's how that kind of goes, and we can look at this sketch here which controls the pad. We'll close this down. There's our model, and it's been updated with those dimensions. We got a few more things we want to add in. So let's go back into the spreadsheet. We've got our edge thickness, and that is this bend here. This is the make wall. So we want to go here and we want to look for the length, and it's defaulted at 10 millimeters and the radius is defaulted at 1. So if we forget, our edge is going to be C2. So let's go in here and update this spreadsheet.C2. That's about a ½ inch. And let's pick up our radius while we're here. And the radius is going to be F2, bend radius. So we'll do that. Spreadsheet.F2. So that takes care of that. While we're here, we can also do the K factor, which is E2, and that's going to be right here. Spreadsheet.E2, which is 0.4. So we've got that. And we can go up into the fold, and that K factor has been hard coded as 0.5. So we want to do a spreadsheet.E2. Takes care of that. So all these properties / parameters now are tied into the spreadsheet. We can go one place and we can go ahead and update this, and it will go ahead and change the model. Well, let's play with the thickness here. So why don't we make this 3.2 millimeters, and let's go back into the model and see what's going on here with that. So Not sure here. Let's go back in. Spreadsheet. So material thickness didn't do anything. So let's go back into the pad and take a look at what went wrong here. So this was set for F2. And let's go back into the spreadsheet. And we made a mistake. We put the bend radius in there. So these are little things that happen. So we want to go with D2. So we'll fix that. And this was a mistake here. So this needs to be D2. And there's our 3.2. So we had a little bit of an oops there. And let's go back and take a look at our model. There we go. So now the thickness is working correctly. These things happen. There's a lot of details. You can get it messed up. You got to play with it. Go in, see if things are working as expected. If they're not, go back, scratch your head, see if you can figure out what's going on with that. So that's kind of what we did there. And so this is really convenient, and you go ahead and let's make this 80 millimeters. Go back and take a look at the model. Shortened it up a little bit. It's very convenient. Now, there's a few other things that you can do with this. There's actually a lot of things, but you can put cells down here. For example, K factor. We could create a formula for bend allowance, and then the bend allowance is going to be a function of your material thickness and your bend radius. And I've got formulas in my blog for that. It isn't really necessary here, but just as an example, it could be done, and that'll give you a bend allowance, which actually will be possibly useful if you're going to work on a drawing and you actually need to know what that is. But let's go back here and put this back at 1.6 millimeters. So the next thing we can do is if we go into this and we do a right click, we can insert a row above. And I'll show you quickly. Let's say we wanted to have these dimensions as inches instead of millimeters, and we wanted to do a conversion. We want to put a formula in here. So what you can do here is, let's just say we want to have 4 inches up here, and we want this to be dependent on the 4 inches. So we can actually put a formula in here. So we can go ahead here and we can say this cell, which is now A3, is going to be equal to the cell A2 times 25.4 millimeters. So we can do that. And so what will happen here is this cell will recalculate. As you can see, it went from 80 to 101.6. It'll recalculate, and that is the 4-inch millimeter equivalent right here. So you could do this with all the cells. I'll save everybody the time. It's the same scene for every single one of these cells, but it's an example of the calculation expression capability. It's very handy. You need to have the equal sign in there. Don't forget that. And we can go here and we can do a little formatting if we want. So that's kind of how that works. And it's nice. It works pretty well. And I've used this on my models to good effect. And I guess we can go here and play with one more parameter. We can make this 20 millimeters and go back and take a look, and we can see what's going on here. This model is behaving as expected. It's changing based on the parameters in the spreadsheet. It's a lot easier to do it that way, in my opinion, instead of chasing around all the properties wherever they may be. If you got a large model and you got 10 or 15 of these things going on, you can go ahead and put them in a spreadsheet, and it's all in one place. It works kind of nice. So that's kind of it for the spreadsheet. So do like, subscribe, and comment as you feel appropriate. And thanks for watching, and happy bending.